So how was this developed? In olden times, they used an equipment similar to this picture that's showing here. And what they would do is they would have puffs of air that would go into these rotating disc. So this disc would rotate, and then they would figure out by the sound that was being produced by air flowing through these pitches, whether it was loud or not. They would move it by hand, crank it by hand. Air raid sirens. Have you ever seen a World War II movie? Yeah? The sirens, have you heard those? Sounds like these. Pretty much the same principle. They would turn it by hand, and because there was a passage of air, it would make noise. And based off of this, they would tell whether the pitch was high or low. Nowadays, we just put it through a digital device, and that tells us what the pitch is. And when two frequencies are very close to each other when they're coming in, they can produce beats. Do you remember what beats were? The whoop, 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 whoop sound were the frequencies that are close enough together. Less than 12 hertz, you get pretty good beats. Okay, so there are two categories of pitches. One are called definite, and the other one is called indefinite. A definite pitch is a sound or a note where it is possible or relatively easy to differentiate. For a definite pitch, it has to be a harmonic spectrum. Basically, in terms of frequencies, 2 times F0, 3 times F0, fundamental frequency, and moving onward. An indefinite pitch is where it is extremely difficult to separate out certain frequencies from the multiple frequencies that are produced. So for example, percussion instruments, they are very, very difficult to have a particular pitch. Whereas violins or pianos or any of those instruments, you can tell, right? 440 versus 512. Absolutely. This is what note you've hit. So that's the difference between definite and indefinite pitches. And another word, inharmonicity. Those are related to indefinite pitches. So pitch cannot be in isolation. It depends on loudness. So as loudness of a pure tone increases, the pitch may also increase or decrease depending on its original frequency. Note this very important term. Remember, if you increase the loudness of a sound wave, its frequency may or may not change. Actually, very rarely changes, right? All you're doing is you're increasing the amplitude. But what is pitch? Pitch is what we hear. So a louder tone will appear like the pitch has gone up. Even though if you put it through the detector, it'll sound the same. It'll have the same frequency, right? So you cannot call it independent. It is a very subjective term. For a frequency of 200 hertz, the pitch decreases if the loudness is increased. However, between 1,000 and 3,000, pitch remains independent of loudness. But above 4,000, as you increase loudness, the pitch seems to increase as well. So the pitch increases. And you would think that that would be a problem for when you play music, but it generally is not, because a music is never played in isolation. It's always played with other things. Even the fact that you have sympathetic vibrations when you're playing your guitars, even when you're playing them all by yourself, right? All of those sympathetic vibrations make it into a complex tone. And complex tones do not have the same requirements as a pure tone does. So yes, you will feel that, but it won't be a bad effect.